Hello everybody, welcome. Today what we're looking at is we're going to be looking at the normal model and empirical distribution. This is the last thing in our first unit. So with that being said, let's get started. So what I want to do first is you're going to notice throughout you have a bunch of these. What these are, it's just like a numbered line. So what we're going to do is we're going to start by drawing a normal model or the bell curve, okay? I'm guessing some of you may have seen this before. I don't like the start of that already. Okay, so what this looks like, this should look like, okay? It starts at the left, goes up till it gets to a point, and at this top point, it's our mean, median, and mode, and it comes down, and this is perfectly symmetrical, okay? And at this center point, we have our mean, or what we're gonna call it, x hat, because that's what we see it in our calculator, okay? That's at the middle, okay? Then, on the left and the right side, okay? What this will be, it's -1 standard deviation away, 1 standard deviation away. You're probably thinking, Kephoria, I don't know what you're talking about. That's okay. What we're doing right now is we're just kind of outlining it, okay? We're showing what a generic normal model looks like, okay? Then -2 standard deviations away, 2 standard deviations away, and then finally, we have 3 standard deviations away and -3 standard deviations away. And what I mean by this is -3 standard deviations away from our mean, okay? All of these are referring to our mean, okay? So this is kind of what a normal model looks like, okay? So this says, when can we use the normal model and why, okay? So what the whole point of the normal model is it allows us to be able to estimate population percentages, or it allows us to kind of figure out like what percentile we were in. So as an example, you remember when you were a kid and you went to the doctors and they measured your height and weight and they said, oh, blah, blah, you're this tall, you're in the 95th percentile of kids your age. So what that percentile comes from, it comes from the normal model. What else uses the normal model? Well, for those of you in AP classes, all of the AP exams are based on the normal model. Okay, so basically how that is they find your mean, they find your standard deviations, and then they compare you to one another. And they're going to use the empirical rule to really kind of separate you from one another. So when can we use the normal model and why? Well, we're going to use the normal model when the shape of our data is symmetrical or mostly symmetrical, and when it's unimodal. Okay, and why this is, so why, this is because if it's not symmetric, the normal model will not be as accurate. Okay, so that's kind of just a little bit about the normal model. When do we use it? We use it when the shape is symmetrical and unimodal. And why? This is because if it's not symmetrical, the normal model will not be as accurate, and we want the normal model to be accurate. Okay, so what we're going to do now is on this line right here, I'm actually going to give you a second. If you need to write this chunk down, oh, sorry about that. If you need to write this chunk down, pause the video here because I'm about to erase this because I need some space here. Okay, hopefully you paused. All right, so what we're going to do is we're going to make another. Oh my goodness, that one's just bad. It's much better, okay? So here's what the empirical rule is, okay? There's 3 numbers that go with it. It's 68, 95, and then 99.7, okay? So here's what this tells us, okay? So once again, we have our mean in the middle, and we're going to call it x hat. okay? And what these three numbers are, they're percentages. And the percentages tell us what percent of the population lies within certain standard deviations away. So what this is telling us, from -1 to 1 standard deviations away, 68% of our data will lie in here. Okay? Then from -2 to 2, what that tells us, that's the 95. Okay? From -2 to 2 standard deviations away, 95% of our data lies in there. And then from -3 to 3, we're going to do this one up here. From -3 to 3, 99.7% of our data lies in between there. So, as an example, from -3 to 3 standard deviations, so this whole chunk under the curve, 99.7% of our data lies there. Okay, this chunk between -2 and 2 standard deviations, 95% of our data lives in here. And then this chunk from -1 to 1, okay, 68% of our data lives in here. So what I want you to do, once again, if you do not have this written down, what I recommend doing, pausing this video right here, because I am going to erase this one, so that way we can have a little bit more space for this one, okay? I hope that you wrote small for this. We're gonna break this down even more. We're gonna break it into sections to show the chunks, okay? So, actually, I'm not even gonna erase it all. I'm just gonna erase that chunk, okay? And we'll put this on the top. So from here to here, it's 95. Okay, so what we're gonna do, we're gonna make another normal model. What we're gonna do this time is we're gonna break it down by chunks, okay? So once again, our mean is in the middle, x hat, -1 and 1, 2, 3, -2, -3. And what I wanna do now is I wanna go through this and we're gonna say what percent of our data is in each chunk that we're making, okay? And we're gonna think about why this is. So what we wanna know, how much data is in this chunk and how much data is in this chunk. How we should think about that? Well, we know from -1 to 1 standard deviations away, it's 68% of our data. So this chunk is 68%. So what would be these two chunks? Well, we're distributed evenly on both sides. So really this 68 needs to be distributed evenly here and here, okay? So in this chunk, we're gonna have 34%, and in this chunk, we're gonna have 34%. Okay? Then from here, we need to think about, okay, what about these two chunks? Okay? We know from -2 to 2 standard deviations away, this whole section is 95% of our data, but 68 of that 95 is in this chunk. So how we can find that is we're gonna take 95 and we're gonna subtract 68. And when we do that, we are gonna get 27, okay? So 27% lives